Right now, underneath the soil of Tennessee, Kentucky, and Kansas, something massive is being built. Something that will change every road, every car, and every job in America. We're talking about factories so large they can be seen from space. And inside, robots, thousands of them, racing to build the most powerful batteries ever made. This is not the future. This is happening right now. And America is betting $140 billion to win. In this video, you'll go inside the most advanced electric vehicle battery factories ever built on American soil. You will see how Ford's Blue Oval, GM's Ultium, and Panasonic's Gigafactories are using robots, artificial intelligence, and futuristic automation to build the batteries that will power millions of electric vehicles. Stay until the end, because what we reveal in the final minutes will completely change how you see the road ahead. Here's a question most people never think about. When you plug in an electric car tonight, where did that battery come from? Who made it? Was it a human hand or a robotic arm? And why does it matter so much that America is spending more money on this than it's spent building the interstate highway system? That answer is at the center of everything you're about to see. And trust me, it is far more incredible than you think. $140 billion. Let that sink in. That's the total amount American companies and the U.S. government have committed to building a domestic EV battery supply chain from scratch. Just 5 years ago, nearly 80% of the world's battery production was controlled by China, Japan, and South Korea. Today, America is building its own empire, one gigafactory at a time. And 3 names are leading that charge: Blue Oval, Ultium, Panasonic. Ford partnered with South Korean battery giant SK On to form Blue Oval SK, building 2 megafactories in Kentucky and 1 in Tennessee. General Motors joined hands with LG Energy Solution to create Ultium cells, with plants in Ohio, Tennessee, and Michigan. And Panasonic, the legendary Japanese company that has powered Tesla for years, is now building its largest battery factory ever, right in DeSoto, Kansas. 3 companies, 1 mission: power the American EV revolution. Imagine pulling up to a building the size of 40 football fields. The air smells clean and electric. There are no smokestacks, no noise pollution, just a low, steady hum of machines working in perfect harmony. Security gates, badge scanners, and airlock chambers line the entrance. This is not a traditional factory. This is a precision manufacturing environment where even a single dust particle can ruin a battery cell worth thousands of dollars. Welcome inside. The first thing that hits you when you walk inside a battery gigafactory is the silence. Not total silence, but a controlled, engineered silence. These buildings maintain what engineers call a dry room environment. The humidity inside is kept lower than the Sahara Desert. Why? Because lithium, the core ingredient in EV batteries, reacts violently with moisture. 1 drop of water in the wrong place can destroy an entire batch of cells. That's why robots, not humans, do most of the work in here. But here's what I want you to think about as we go deeper inside this factory. If these robots are so advanced, if this technology is so precise, then why did America fall so far behind in battery manufacturing in the first place? And how is it planning to catch up to China, a country that has been building battery factories for over 2 decades, in just a few short years? The answer lies in 3 words: speed, scale, and automation. Let's break it down. Every EV battery starts with raw materials: lithium, nickel, manganese, cobalt, and graphite. These minerals are mined from places like Australia, Chile, the Democratic Republic of Congo, and increasingly from American soil. They arrive at the factory in industrial containers, where automated conveyor systems sort, weigh, and analyze them with laser precision. Robotic arms, some stretching over 20 feet tall, lift and position these massive containers without a single human touching them. Inside what engineers call the electrode mixing room, the raw materials are combined into a liquid slurry like a thick metallic paint. This mixture will eventually become the heart of the battery cell. The recipe is a tightly guarded secret. Each company has its own formula, optimized for energy density, charge speed, and longevity. Giant industrial mixers the size of small houses blend these materials under computer-controlled conditions. Temperature, pressure, and timing are all managed by AI systems running thousands of calculations per second. Once the slurry is ready, it's time for electrode coating. This is one of the most visually stunning parts of the entire process. Enormous rolls of ultra-thin copper and aluminum foil, thinner than human hair, are fed through coating machines at speeds of over 100 feet per minute. The metallic slurry is applied in microscopic, perfectly even layers. A single mistake in coating thickness can reduce battery performance by up to 20%. The machines measure this in real time, making micro adjustments thousands of times per second. And here's something the factory engineers told us that completely stopped us in our tracks. The coated electrode foil produced in a single blue oval factory in 1 week. If you laid it end to end, would stretch from New York City to Los Angeles and back. That's how massive this production scale is. But coating is just one step. What happens next is where the real magic begins. And it involves a process so precise it has to be done inside a room with zero oxygen. Are you curious? Keep watching. After coating and drying, the giant electrode rolls are moved to the slitting room. Here, industrial laser-guided cutters slice the wide rolls into precise, narrow strips with tolerances measured in microns. That's 1/1,000,000th of a meter. These strips will become the positive and negative electrodes inside each battery cell. Robotic arms transfer the slit rolls to the next stage without human contact. Every movement is tracked by overhead cameras and logged in real-time data systems, creating a complete digital history of every piece of material. Now we reach the most critical stage of all, cell assembly. This is where the battery actually comes to life. In this section, the positive electrode, the negative electrode, and the separator, a membrane thinner than a strand of spider silk, are wound or stacked together with absolute precision. The machines doing this work operate so fast, the human eye can barely follow them. They produce thousands of cells per hour, and every single one must be perfect, because one faulty cell in a battery pack can mean the difference between a safe car and a dangerous one. Once the cell structure is assembled, it's placed into a sealed metal or pouch casing. Then comes the electrolyte, a liquid chemical compound that allows electricity to flow between the electrodes. This step happens inside sealed chambers filled with inert gas, because electrolyte reacts explosively with air and moisture. Robotic needle systems inject a precise microdose of electrolyte into each cell. Not a milliliter more, not a milliliter less. Then the cell is immediately sealed. What was once raw minerals from a mountain in Chile is now a living, breathing battery cell. But a freshly assembled battery cell cannot be used yet. It must go through a process called formation. Essentially, its first charge and discharge cycle. This wakes up the chemistry inside and stabilizes the cell. Formation racks holding thousands of cells line the walls of entire warehouse-sized rooms. Each cell is connected to a charging station and monitored by software that watches voltage, temperature, and current 24 hours a day. This process takes several days, and it's during this time that the cell's true performance characteristics reveal themselves. Now, here's a question that most EV owners have never thought to ask. Out of every 1,000 battery cells produced in one of these gigafactories, how many do you think fail quality inspection? 10? 50? 100? The answer might shock you. And it reveals exactly why the robotics and AI systems inside these factories represent the most important technological investment America has made in decades. We'll reveal the answer in just a few minutes. But first, let's meet the brain behind everything you've seen so far. Every gigafactory runs on what engineers call a manufacturing execution system, or MES. Think of it as a factory's central nervous system. This AI-powered platform receives data from hundreds of thousands of sensors placed throughout the factory floor. It monitors temperature in every room, tracks the position of every robot, analyzes performance of every machine, and flags any abnormality, often before a human operator would even notice something is wrong. In a blue oval factory, the system processes over 2 terabytes of data every single day. The sensors inside these factories are almost unbelievable in their sophistication. Infrared cameras detect heat signatures invisible to the human eye. Ultrasonic sensors measure the thickness of electrode coatings to within nanometers. Vision systems using cameras with 50 megapixel resolution scan every cell for microscopic defects. Gas sensors monitor the air composition in every room simultaneously. And all of this data streams continuously into the AI brain, which uses machine learning algorithms trained on millions of previous production cycles to make real-time decisions about quality, speed, and safety. After formation, every single battery cell passes through a battery quality test. And yes, that pun is absolutely intended. Each cell is subjected to electrical performance testing to measure capacity and internal resistance, X-ray scanning to detect internal structural defects invisible from outside, pressure testing to ensure the seal is airtight, thermal imaging to check for hot spots, and cycle testing where cells are charged and discharged repeatedly to verify long-term performance. This is where we answer that earlier question. Out of every 1,000 cells produced, fewer than 3 typically fail. That's a defect rate of less than 0.3%. Individual cells that pass quality testing are grouped together into modules. Multiple modules are then assembled into a complete battery pack, the large, flat unit that sits beneath the floor of an electric vehicle. This is where the factory transitioned from cell-level precision to vehicle-level engineering. Robotic arms weld, press, and bolt components together with forces measured in thousands of pounds. Automated guided vehicles, essentially robot forklifts, transport heavy pack assemblies across the factory floor without any human driving them. One of the most underrated engineering challenges in EV battery design is heat. A lithium battery that gets too hot can catch fire. One that gets too cold loses performance dramatically. Inside every battery pack, engineers install an intricate thermal management system, a network of channels that circulate liquid coolant around every module, keeping temperatures within a narrow optimal range regardless of whether you're driving in a Phoenix summer or a Minnesota winter. Robots install these cooling systems with millimeter-perfect precision, because even a slight misalignment can reduce cooling efficiency by 30%. At this point in our factory tour, a thought probably just crossed your mind. With all these robots doing almost everything, what are the humans actually doing in here? And here's where the story gets really interesting, because the relationship between human workers and robotic systems inside a gigafactory is not what most people expect. It's not robots replacing humans. It's something far more fascinating and far more hopeful for American workers. We're going to show you exactly what that looks like right after this. When Blue Oval SK's Kentucky factory reaches full capacity, it will employ over 5,000 workers. When Ultium Cells Ohio plant runs at full speed, another 1,100 jobs. Panasonic's Kansas facility, projected to create 4,000 direct jobs and thousands more in the surrounding supply chain. These are not the dirty, dangerous factory jobs of the past. These are high-skill, high-pay positions in robotics programming, AI system monitoring, battery chemistry, quality engineering, and advanced manufacturing. The robots didn't take these jobs. They created better ones. In certain areas of the factory, you'll find a remarkable sight. Humans and robots working side by side, sometimes inches apart. These are collaborative robots, or robots. Unlike traditional industrial robots that must be caged away from humans for safety, robots use advanced sensors and AI to detect human presence and adjust their movements instantly. A human worker might guide a cobot arm to the right position using a tablet interface, and then the cobot carries out the repetitive, heavy, or precision task, while the human moves on to the next decision that requires human judgment. Let's zoom in on Blue Oval SK, Ford's battery joint venture with SK On. In Glendale, Kentucky and Stanton, Kentucky, Ford and SK On are building 2 facilities under one roof, a combined complex called Blue Oval City. This isn't just a factory. It's an entirely new industrial city. It covers more than 3,600 acres, larger than the entire city of San Francisco. It includes a battery plant, a future Ford truck assembly plant, a supplier ecosystem, and worker training facilities. Ford calls it the most significant investment in its 120-year history. Ultium Cells, the GM and LG Energy Solution Partnership, is taking a different approach. Rather than concentrating everything in one location, Ultium is building a network of factories across multiple states. Their Lordstown, Ohio plant, Built on the site of the famous Shuttered GM assembly plant, it was the first to open their Spring Hill, Tennessee facility began production in 2023. A third plant in Lansing, Michigan is under construction. Together, these facilities will produce enough battery cells to power 1 million electric vehicles per year when fully operational. And then there's Panasonic, the quiet giant of the American battery race. Panasonic has been making batteries for Tesla's vehicles since 2014 at the original Nevada Gigafactory. But their new plant in DeSoto, Kansas, is a different beast entirely. It's Panasonic's largest investment in its 105-year history. A $4 billion facility covering 4.7 million square feet. When complete, it will produce 30 gigawatt hours of battery capacity per year. That's enough to power approximately 300,000 additional electric vehicles, and it will be powered significantly by renewable energy. Now, if you've been paying close attention, and I know you have, a critical question should be forming in your mind. All of this investment, all of these robots, all of this technology, is it actually working? Is America really catching up to China in battery manufacturing? Or is this all a very expensive, very ambitious dream that reality is about to crash into? This is a question that keeps battery industry analysts up at night. And the answer, depending on who you ask, is both incredibly inspiring and honestly a little bit complicated. Let's go there. Here's the honest truth. China currently controls approximately 75% of global battery cell manufacturing capacity. Chinese companies like CATL and BYD have been building gigafactories for over 15 years. They have mature supply chains, government subsidies, and decades of manufacturing experience. American factories are starting from scratch, often with brand new workforces being trained on technologies that didn't exist 5 years ago. Catching China is not a weekend project. It's a decade-long marathon. But here's what makes the American approach different and potentially more powerful in the long run. America's secret weapon in the battery race isn't volume. Not yet. It's innovation velocity. American factories are being built with next-generation automation from day one. They're incorporating AI quality systems, digital twin technology, and advanced robotics that Chinese factories built a decade ago simply weren't designed to include. A digital twin, for example, is a complete virtual simulation of the entire factory, updated in real time from sensor data that engineers can use to test changes, predict problems, and optimize processes without ever stopping production line. Imagine a perfect virtual copy of the Blue Oval battery factory, existing entirely in a computer. Every robot, every conveyor, every mixing chamber, every coating machine, all modeled with exact physical accuracy. Engineers can run simulations in this digital twin to answer questions like, what happened to production throughput if we speed up the slitting machines by 15%? Or, if the electrode coating thickness changes by 2 microns, how does that affect the final battery's energy density? These questions can be answered in minutes without risking a single real battery cell or a single second of downtime. One factor that is fundamentally reshaping the American battery landscape is the Inflation Reduction Act, signed into law in 2022. This legislation provides billions of dollars in tax credits for companies that manufacture batteries in America using materials sourced from America or its trade partners. For companies like Blue Oval, Ultium, and Panasonic, these tax credits can be worth hundreds of millions of dollars per year, dramatically improving the economics of domestic production. It's essentially the U.S. government telling the private sector, build it here and we'll help you pay for it. But gigafactories don't exist in isolation. Behind each one is a massive ecosystem of suppliers, lithium refiners, separator film manufacturers, electrolyte chemical producers, battery management system designers, packaging specialists. Each of these industries is also building up domestic capacity at unprecedented speed. Towns near battery gigafactories are seeing populations grow, new highways being built, schools expanding, and entirely new business districts forming. The battery supply chain isn't just powering electric cars, it's rebuilding entire American communities. By now, you understand what's being built. You understand the scale, the technology, and the stakes. But here's the question that takes this from interesting to truly mind-blowing. 10 years from now, what happens to all these batteries once the electric vehicles they power reach the end of their useful life? Because inside these same robot factories, engineers are already working on the answer to that question. And it involves something that could completely transform not just the auto industry, but America's entire energy grid. Are you ready for this part? When an EV battery loses roughly 20 to 30% of its original capacity, it's no longer ideal for powering a car, but it still has enormous value. Second life battery programs are being designed alongside Gigafactory construction to repurpose these used battery packs as stationary energy storage systems. Imagine battery packs from retired Ford F-150 Lightnings being repurposed to store solar energy for neighborhood hospitals or military bases. GM's Ultium team is already testing this concept. A battery that powers your truck for 15 years might then power your neighborhood for another decade. And after Second Life comes recycling. This is where another generation of robots enters the picture. Companies like Redwood Materials, founded by Tesla's former CTO, are building automated recycling facilities where robotic disassembly systems take apart used battery packs, separate the valuable materials, and send them back into the supply chain. Lithium, cobalt, nickel, and graphite recovered through recycling can be just as pure as freshly mined materials, but at a fraction of the environmental cost. The battery doesn't end. It transforms. While all of this is happening with lithium-ion batteries, the technology we have today, engineers inside these same gigafactories are quietly preparing for what comes next. Solid-state batteries replace the liquid electrolyte with a solid material, promising energy densities 2 to 3 times higher than current batteries, meaning EVs could travel 600 to 800 miles on a single charge. Toyota, Quantum Cape backed by Volkswagen, and Samsung are all racing towards solid state. And the robot factories being built today are being designed with the flexibility to adapt to this new chemistry within years, not decades. And here's something that almost nobody is talking about. These battery gigafactories being built by Blue Oval, Ultium, and Panasonic, they are not just producing batteries for cars. They are quietly laying the foundation for something far bigger. Something that could completely redefine how America generates, stores, and distributes electricity across the entire country. We're talking about a technology shift so fundamental that it could make today's power grid look as outdated as a horse-drawn carriage. And the robot factories you've been watching throughout this video are the starting point. Keep watching. Electric vehicles are not just transportation. They are mobile energy storage units. A fully charged Ford F-150 Lightning carries enough energy to power an average American home for 3 days. Vehicle-to-grid technology, or V2G, allows EV batteries to send power back to the electricity grid during peak demand periods, essentially turning millions of parked cars into a distributed network of energy storage. Ford has already enabled this in the F-150 Lightning. GM is building V2G into future Ultium-powered vehicles. The battery factory and the power grid are converging into one giant, intelligent energy system. The human story inside this revolution deserves special attention. Many of the workers being hired for Blue Oval, Ultium, and Panasonic factories are coming from traditional automotive, coal mining, and steel manufacturing backgrounds. Companies are partnering with community colleges, technical schools, and union training programs to rapidly upskill these workers in robotics operation, battery chemistry safety, AI system monitoring, and advanced manufacturing protocols. This isn't just an industrial transition. It's a workforce renaissance, giving American workers some of the most technically sophisticated manufacturing skills in the world. One of the most remarkable aspects of this entire story is the sheer speed at which these facilities are being built. The Ultium Cells plant in Lordstown, Ohio, covering over 2.8 million square feet, went from groundbreaking production in under 2 years. That a factory the size of 50 football fields, built from empty ground to operational manufacturing in 24 months. Construction crews worked around the clock, with robotic surveying tools, drone monitoring, and AI-managed supply logistics, keeping the construction timeline on track with precision never seen before in American industrial history. Inside these gigafactories, safety is not an afterthought. It is engineered into every square inch. Thermal runaway. The process where a lithium battery overheats and catches fire, is taken extremely seriously. Factories feature advanced fire suppression systems designed specifically for lithium fires, which behave very differently from ordinary fires. Robotic systems can detect the early thermal signature of a problem cell and isolate it within milliseconds, long before any human could react. Emergency ventilation systems, gas detection arrays, and automated lockdown protocols protect both workers and irreplaceable equipment inside. Here's a question that electric vehicle critics often raise. Are battery factories themselves clean? It's a fair question. And the answer is, they're getting there fast. Panasonic's Kansas facility is targeting zero-carbon operations, powered by wind and solar energy native to the Kansas plains, one of the windiest and sunniest regions in the country. Blue Oval and Ultium have both committed to powering their facilities entirely with renewable energy by 2030. Many are also implementing water recycling systems, zero landfill waste policies, and building designs that maximize natural light to reduce energy consumption. Let's take a quick look at where America stands in the global battery race right now. In 2020, America's share of global battery manufacturing capacity was less than 1%. Today, with projects under construction and announced, that figure is projected to reach 12 to 15% by 2030. That's still behind China, but it represents the fastest industrial capacity build out in American history. And critically, these are not just assembly operations. They are full value chain manufacturing facilities, from raw material processing to finished battery pack production, giving America genuine industrial sovereignty in this critical technology. If this story is surprising you, if you didn't know America was building on this scale, then imagine how many other people in your life don't know this either. This is the kind of content that genuinely deserves to be shared. Hit that share button right now and show someone you know what's actually being built in their country. And drop a comment below. I want to know, which of these three companies do you think will dominate American battery manufacturing in 10 years? Blue Oval, Ultium, or Panasonic? Your answer might surprise even yourself. Let's continue. Behind all the robots, the sensors, the AI systems, and the billions of dollars, there are human beings with a vision. Engineers who have spent their careers dreaming of the moment when America would build its own battery future. Workers who drove hours to a new factory because they believed in what was being made there. Community leaders who fought to bring these facilities to their towns because they saw what it would mean for their children's futures. This industrial transformation is powered by electricity, but it's driven by something much older and much more powerful: human ambition, American determination. By 2030, industry analysts project that electric vehicles will represent 40 to 50% of all new car sales in the United States. That means millions of batteries produced every year in American factories by American workers using increasingly American-sourced materials powered by American renewable energy. The robot factories you've seen in this video are not the end of the story. They're the opening chapter. The technology will get faster, cleaner, cheaper, and more powerful with every passing year. And America, for the first time in decades, is not watching from the sidelines. It is building the field. Before we get to our final message, and it's one I want you to really hear, if you've made it this far in this video, then you are exactly the kind of curious, forward-thinking person this channel was built for. We cover the robot factories, the automated systems, and the future technologies that are quietly reshaping our world. And we do it in a way that's honest, inspiring, and actually interesting. If that sounds like something you want more of, subscribe right now and hit the bell icon, because our next video is going to go even deeper inside a place most people never get to see. Here is the truth about this $140 billion battery race. It was never just about cars. It was never just about China. It was never just about technology. It was about America asking a fundamental question. Can we build a future with our own hands? And inside those massive, quiet, robot-filled factories in Kentucky, Tennessee, Ohio, and Kansas, the answer is being built cell by cell, module by module, pack by pack. The road ahead is electric. The factories are running. The robots never sleep. And the future, for the first time in a long time, is being made in America. The race isn't over. In fact, it's just getting started.